Today I'm going to go over some very basic electrical troubleshooting, and it's focused primarily on automotive and motorcycle applications, but you could really apply this to almost anything. So let's get started. Okay folks, I'm going to try to keep this short and sweet for you here today, but please remember to like, subscribe, and leave your comments. Basically what I'm going to try to share with you here is some very basic measurements for automotive or motorcycle applications or anything that uses a 12-volt battery. So what I have here is a battery out of a motorcycle. I've got some typical things that you would find in a vehicle, such as a headlight bulb, a brake light and turn signal, a switch, blade fuse, and the old barrel style fuse. So what I want to do is take some measurements, and I have a very cheap Harbor Freight meter here. Harbor Freight, Harbor Freight, and this thing will take pretty much any measurement that you'll need to troubleshoot your vehicle. The ones we're going to be looking at today specifically are DC volts, and you can see I have to select a range here, and this would be from millivolts all the way up to kilovolts, okay? But we're going to be measuring a 12-volt battery, so we want to be in the 20-volt range. You always want to select something above the item that you're going to measure. This thing also does have some AC voltage functionality, and as you can see, it's on high voltage right now, 750. That would be like if you're measuring your washer and dryer circuit, 240 volts. 200 volts is for your standard 110, 120 volt outlet. And here we have DC amps, and we will get into that today. This measures up to 10 amps DC. We won't go into these measurements, but we will go into the ohms or the resistance measurement. Essentially there I'm going to be showing you how to measure continuity, but it's really a resistance measurement. So first things first, let's go ahead and measure the voltage on this battery. So we'll set it at our 20 volts, and hopefully you can still see that. And I will put the red terminal on the positive, black on negative, and I'm reading about 13.08 volts. And that's because I just had the charger on this thing, and I do want to put the charger back on so you can see what the voltage looks like there with the charger on. And always use red on plus, black on negative. And here we can see that our charging voltage is about 13.4. So that would be typical of the alternator on your car or the stator charging system on your motorcycle. And there will be a voltage regulator, and it is going to keep it within a range. You know, like the charging voltage range is always something above the standing voltage. So typically, you know, you're always going to be like somewhere between 13 and, you know, like 16 volts or something like that. I don't know what the max is. Anyway, I don't want to guess at that, but anyway, so, you know, we're sitting at about 13.5 volts, which is great, you know, for charging. And also, I do want to say, if you do have a battery in a vehicle and you're going to let it sit, you probably want to put a trickle charger on it, because, or a smart charger. If you just leave it sit, there will be some parasitic drain or something like that, or, you know, I mean, it'll go bad, and they go bad very quickly within a year or two. If you don't have a trickle charger on it, it's going to go bad on you. So save yourself some money, get a trickle charger, and you can extend the life of your battery. All right, so we'll disconnect that. All right, now what I want to do, we got the voltage measurement. I want to show you continuity or resistance. So I'm going to change this thing to the lowest resistance setting, which is 200 ohms. This is measured in ohms or omega. And I'm going to test this fuse. Okay, so if I put the leads across the fuse, right now you see that it's open. Okay, let's see this on the camera actually. So you see that it's open, and then when I put the lead on it, you can see that I have continuity, and it's measuring about 8/9 of an ohm, and that's just like a short circuit. Just like putting the leads together on this thing, and that means that the fuse is good. Okay, if you can measure that continuity across the fuse. But if that fuse gets blown, basically it's going to open up just like that, open circuit. Okay, so we know this fuse is good. This is the old barrel style fuse. That one is good. The measurement might bounce around a little bit if the leads are moving. Let's see, here we have a switch. So I'm going to put the leads on the switch. And here we're open. Well, that means that the switch is normally open, but if I press the button on the switch, it's going to close that circuit. It's just like turning on the switch. It's exactly what's happening. We can also check a light bulb. So it's got a high beam and a low beam. So I'm going to put one lead on the ground terminal or negative, and one lead on one side of the positive terminal, I guess on the low beam, and then I'll go to the other side, and that might be the high beam or vice versa. But you can see that both elements on that light bulb are good. Okay, and same thing over here. This one is a little bit more complicated here. Looks like it's got 4 leads on it, but you know, one of them's probably the ground side, and the other is surely the positive side. And this is a turn signal brake light. All right, so we've tested everything that we have here with continuity. So I'm going to go ahead and set this stuff up in a circuit so you can see how the real application would work. All right, so on the negative side, I'm going to use green for ground, and then positive side, I'll just use yellow. And just be very careful not to short these together because there will be a big spark and you might burn some wires or something. So here on the light bulb, we'll put our negative there, and then we can touch the positive on each side. Low beam, high beam. Okay, so that works. but one problem, we don't connect something directly to the battery in a vehicle, so we have to simulate the real application. So let's put a switch in there. So I'm going to put the negative on one side of the switch, and then I will come out the other side of the switch and it'll still be negative side, and then I will put the negative side on the light bulb. We'll get these out of the way for now, and then finally we can put the positive side on there. Okay, so the light still is not coming on, but when we close the switch, we can see that the light comes on. All right, still a problem with this circuit though, because let's say there's a short circuit in the light bulb, or your wire gets shorted to the vehicle chassis or something like that. You're going to burn up some wires. So what we want to do is put a fuse in this circuit. So just take one side, the positive side, and connect to one side of the fuse, and we'll take another wire, connect to the other side of the fuse, and then back to the light bulb on the positive side, and then close the switch. Looks like my switch is a little bit flaky here, but you see that when we close the switch, the light bulb comes on, obviously. If there was a short circuit, this fuse would open up if it has the correct rating. Remember, well, we'll get into current in a minute, but the fuse has to have the correct rating and not be, this is actually a 30 amp fuse, so the rating of that is way too high for this light bulb. You probably want to have like a 1 amp fuse or a half amp or something like that. All right, so back to this. Now we're going to take a current measurement. So what I want to do is put my meter on amps, DC amps, and I don't know, if we put it in on the 10 amp range, that's probably the safest. It's not going to take anywhere near 10 amps to light up this light bulb, but just to be safe. And then I have to put the meter in series with the circuit. So what I'm going to do is just take this fuse out of the circuit for now. I'll connect one side of the meter to the positive terminal, and then this is going to be on the other side, but it's in series. It's in series. It's just like having this lead connected to the positive of the battery, but we're going through the meter, okay? And now we'll close the switch, and if that is correct, it looks like it's taking about 4 amps to drive that light. That does seem a little bit high to me, but who knows? I mean, I don't know how much current these halogen bulbs take. I suppose that could be realistic. So anyway, that is our current measurement. So just to summarize here, we've got, and I'm going to disconnect this just so we're safe here. So we just did our current measurement. If I put this back to, we've got a common lead, so volts, ohms, and milliamps. If I switch this to DC volts, I can see what the voltage is on the battery. And right now we're sitting at about 12.8. So it did, voltage got pulled down a little bit from what we've been doing here. If I flip the leads, it's just gonna read a negative voltage, which is fine. So put the red on the plus, black on negative, 12.85 volts. If we want to check a light bulb or a fuse, we just switch this thing down to the resistance or omega ohms measurement, and typically you would want to use the lowest ohm setting there to measure continuity. And the fuse is still good. Okay. Measure across the fuse, just like a short circuit. And if it's open, it's measuring infinity, closed, short circuit. Okay. Same thing with the switch. You know, I mean, you can, but the switch is open. When I press it or close it, I'm measuring continuity across the switch. Closed, open. Okay, so those are the basic measurements, and hope that helps you. Thanks for watching.